So let's look at our first triple integral involving spherical coordinates. So here I want us to evaluate the triple integral over the region E, 16z dv, where E is the upper half of the sphere x squared plus y squared plus z squared equals 1. So this is a sphere of radius 1, right? And we're only looking at the upper half, right? So just the upper half here. And so if we want to describe the upper half of the sphere, it's pretty easy in spherical coordinates. Rho goes between 0 and 1. Theta goes from 0 to 2 pi, and then phi goes from 0 down to pi over 2, because it's only the upper half. If it was the entire sphere, it would be 0 to pi. And so now that we've described our region, we're ready to start looking at this triple integral. So 0 to 2 pi, 0 to 2 pi, 0 to pi over 2, and 0 to 1. So we got to convert 16z. This would be 16 rho cosine phi. And remember, because we're using spherical coordinates, we get an extra rho squared sine phi, d rho, d phi, d theta. So you're going to integrate first with respect to rho. So you'll get we get 6. So first I should multiply 16 rho cubed cosine phi sine phi d rho d phi d theta. So now I can integrate with respect to rho. Oh, and this should have a 0 to 1 there. 0 to pi over 2, and then this will be 4 rho to the 4th. And then those are all constants, so it'll just be cosine phi, sine phi, d phi, d theta. So you're going to end up with a 4, which I'll pull out in front. Okay, and then I do a u substitution, u being sine theta. So then when I integrate, this becomes 4, the integral from 0 to 2 pi, sine squared, not theta, sorry, that should have been sine of phi. So when I integrate, I'll get sine squared phi over 2. So then when I plug in my bounds, I'm going to get a 1 there. So it'll be a 1/2, which I can pull that 1/2 out and becomes a 2. The integral of 1 would be theta. So then you're going to get 4 pi. So in the end, my answer is 4 pi.